Question 8a. Evaluate without using tables. 5 log 2 plus log 40 minus log 12.8. Solution. You have the given expression and two laws are combined, addition and subtraction. In order to apply the laws, the coefficient of the log need to be 1. So you take this 5 back to 2, it becomes power. So you have log 2 power 5 plus log 40. You convert this from decimal fraction to ordinary fraction. You have log 32, that is 2 power 5 plus log 40 minus log 64 over 5 if you reduce this fraction. The addition law implies multiplication of the numbers. Subtraction implies quotient, which is division. So we have log bracket open 32 times 40 divided by 64 over 5. When dividing fractions, you can write this as over 1. Division sign changes to multiplication. The fraction at the right side of the sign is inverted. Hence, you have this result. If you divide 32 by itself, you have 1. Divide 64 by 32, you have 2. Divide 40 by 2, you have 20 times 5 in this form. That is log 100. Remember, the common base here is 10. When no base is given to you, you work with common base 10. In order to have log 10 base 10, which is 1, we have to express log 100 as log 10 square. By power law, 2 comes back to multiply. The base here is 10. Log 10 base 10 is 1. So you have 2 times 1 equal to 2. Question 8b. Find the equation of a curve which passes through the point minus 2, 5 and has a gradient of 6s squared plus 8s minus 3 at any point on the curve. Solution. The gradient is represented by dy ds equal to the given function. To get the equation of the curve, that is why you have to integrate both sides. Integration is the reverse process of differentiation. Before then, multiply through by ds to clear fraction. Then you integrate both sides. If you integrate dy, you have y. When integrating algebraic functions, you add power 1 to the existing power and divide by the sum of the powers. So if you add 1 to 2, it becomes 3. So you have 6s cubed over 3 plus the power here is 1. When you add 1, it becomes 2. You have 8s squared over 2 minus. When you integrate a constant, it attracts the variable you are working with. So if you integrate 3 with respect to ds, you have minus 3s, then plus constant c, which is always added when working with indefinite integrals. So y is equal to this. We need to get c, and you have this ordered pair, which means s is equal to minus 2, y is equal to 5. You come here and replace s and y with minus 2 and 5 respectively. You have this result. When you simplify, you have this and this, then 5 minus 6 equal to c. Therefore, c is equal to minus 1. The required equation is coming back here. You replace c with minus 1, you have this result. Question 8c. Differentiate y equal to 3s squared plus 4s minus 5 with respect to s. You have the given algebraic function. You simply use power rule of differentiation to get the result. So the change in y with respect to s is dy ds. By power rule, the power is used to multiply the coefficients. That is 2 times 3, 6. You subtract 1 from the power, you have s. That is 6s. Plus the power here is 1 times 4 is 4. If you subtract 1 from 1, here becomes s power 0, which is 1. The differential of a constant is 0. So dy ds is equal to 6s plus 4.